All right. Hey, folks. Good to see so many people in the room. Can everyone hear me fine? Great. So my name is Boris Smus. I'm an engineer in the Chrome Developer Relations team. And this talk is called Fast User Interfaces for the Cross-Device Web. So before talking about this, let me motivate the subject a little bit. Who cares? And I care, and you should care, because this is the current state of mobile internet usage compared to desktop internet usage. So you can see the projected crossover point for when mobile becomes more used than desktop is sometime around 2013, 2014. This is all internet use, so not just web. The web is currently about 10% of all, mobile web is about at 10% of all web usage, and it's been doubling every year. So expect this to change very drastically. Note that I call the talk cross-device and not mobile, because the term mobile is a little bit overloaded. Does it include tablets? Does it include other kinds of devices like TVs, cars, etc.? And what's the opposite of mobile? Stationary? Desktop? Not clear. So I'm not going to jump into pedantic discussions about this. Instead, clearly, this is not a mobile device. So this is a desktop, and many people still think of this as the target for the web. But in fact, the web looks a lot more like this. We have a mess of devices that all access, that all expect web content to serve correctly for them. Tablets, smartphones, etc. It's a very complex landscape, and it's only going to get more complex and more interesting with future interactions that can include gestural UIs, hand tracking, full body tracking, etc., or audio input. So how can we talk about this broad topic? There are still a set of common issues that we need to tackle for all of these problems that I've discussed. We have a wide variety of form factors, as you saw a couple slides ago. In addition, we have CPUs and networks that are much, much slower and much less predictable in many cases on mobile devices. We need to deal with new kinds of input, specifically touch and multi-touch. And we have issues with developing when your host machine is not your target machine. So I'll talk more about that in addition. So these are all issues, but this is also an outline for the rest of the talk. So let's jump right into the form factor question. And how do we support multiple devices that access our site? First extreme is we simply create one version. And some people do this. Some of the examples of sites that take this approach are shown here. You can see text that's not very clearly readable. It's very small on a mobile device. Text that's being cut off because the developers didn't intend it to be used on such a screen. Or in this last example, we have actually two versions, one of which says the device doesn't work on your phone, or the application doesn't work on your phone, sorry. So this is not a very good extreme to be at. The other opposite end of the spectrum is to create a version for each device. So we have here a very incomplete list of some devices in the market. And you could simply say, OK, let's develop a version for each. You can see this is 10 devices. There's probably hundreds and maybe thousands of devices out there. It's simply not feasible to do this, especially if you take into account the number of browsers that exist on some platforms. For example, Android supports a wide variety of browsers. So we need to find some sort of middle ground, keeping in mind this trade-off that the more versions you create, the better each one can be from a user experience perspective, but the more effort it'll require. So the question then is, where can we save some effort? And how can we make a better decision of what to build? So we have two sort of axes to choose from. We have platforms and form factors. Let's talk about platforms. So native platforms, this is a bit of an aside, they provide human interface guidelines and UI frameworks. So this is on the right, example of a human interface guideline for Android. It provides a set of common UI controls, and the corresponding UI framework makes it really easy to build that kind of UI for a developer. So the point of this is to make it, to have developers fall into a pit of success by default. If you try to do this sort of thing on the web, as some people have, you quickly run into problems. So emulating native UIs is a perilous path. It's hard to implement. You're going to be always slightly off in look and or feel. And even once you've done this painstaking effort that some people have taken, you still have to repeat that same process on every other platform that you want to support. So if you want to read more about some poor soul that did this, you should check out this guy's blog post. It's very detailed and good. He goes into details like, you can see a little bit of diagonal artifact here in the CSS version of this button. So that kind of level of detail. So generally speaking, platform differences are both small, so we can have different styles for buttons, but some of them may appear bigger. For example, the placement of navigation bar. The Android Human Interface Guidelines says to place it at the top of the screen, whereas the iOS one places it on the bottom. Fairly major change, but it's important to note that these are differences these are rules that are meant to be broken, and in many cases are. So on Android, many applications place the toolbar on the bottom, whereas on iOS, for example, on iPad, the guidelines actually say to place it on the top. If we look at form factor differences, though, these are much bigger. We have completely different usage patterns. Phones that you hold with one hand and tablets that you hold with two. Major variations in screen real estate. So these form factor differences, I would say, trump platform differences. So as a first cut, and I'm not saying that this is perfect for your application, we can consider having multiple versions of our site and compromise to phone, tablet, and desktop, just as a starting point. So how do we actually build this? We build this, there's two possible angles to come at it from. We can start from a single version and make tweaks, divergent tweaks to that version, or we can say up front, we're going to build 3 versions and serve the correct one. So the first version. Many of you are probably familiar with CSS media queries. In case you're not, it's an easy way to tweak your CSS style sheets depending on properties of your device. So here I have a media query which says if the screen is less than 1,000 pixels, then hide the sidebar. So this is pretty straightforward and is used to create websites that look like this. So here is a German design magazine. And you can see as I resize the page, the styling changes subtly. You'll notice also that Chrome has a minimum size. So let me show you a cool trick that you can, you may not know. I can actually resize the page using the developer tools. So let me size it back to the correct size here. Switch over to DevTools. And I will override device metrics here and pick the resolution that I want. Just set it to 320 by 480. And you can see I've sized it down to a size that I couldn't use Chrome natively I couldn't resize Chrome to be this small. And you can get a good preview of how these sites look like using this feature. But there's limitations to this approach, right? We're talking here about a shared DOM, shared JavaScript, and simply tweaking the CSS. So if we want to make big changes between form factors, such as this example here where we have Gmail native apps for Android, you can imagine the pain that you would have to go through to use the same HTML and create these separate layouts. A lot of CSS tweaks, a lot of hidden content, a lot of conditional CSS for the two form factors. Also, since we have shared JavaScript in this case, how do we load additional functionality? So one middle ground here between the two extremes of one version and separate versions completely is using media queries in JavaScript. We can do this with the window match media call. And this lets you evaluate arbitrary media queries, as in this sample. So here you can see I'm evaluating this media query, and I'm seeing if it matches or not. You can also listen for changes with this event listener syntax. And here in this example, I'm listening for the orientation media query. And as soon as that changes, so if I switch from portrait to landscape, this will fire, and I can respond to that. It's a much nicer way of going about things than using orientation change. But if we want to completely separate the versions that we want to create, we can take an approach like this. This is really simple code that basically says default to the desktop version, then check for touch support. If there's touch support and the screen is small, serve the phone version. Otherwise, if the screen is large but touch is still enabled, serve the tablet. So here we need to figure out how to know if there's touch or not. Right now, there's not a really good way of doing this on the open web. So we can use Modernizer or other feature detection libraries to do this sort of thing. So modernizer.touch will return true if touch is enabled. But we have media queries that are coming through the pipe. They're not implemented anywhere yet, but we have hover and pointer media queries, which are used to distinguish between pointer or mouse pointer type input and touch input. The other question here is, how do we know what's small enough? Where do we draw the line between phones and tablets? So we can evaluate the media query, but where do we set this boundary? So here's on the right, diagram of various mobile devices and their resolutions in CSS pixels. So it's important here for this discussion to remember that CSS pixels are not the same as device pixels. CSS pixels are scaled to the, they're scaled by the device pixel ratio to be virtually sized, essentially. So the history here is when Apple released the iPhone 4, they had doubled the resolution of both dimensions, creating 4 times as many pixels on the screen. So if they did nothing about this, then sites would render at half size. So they introduced this notion of device pixel ratio, and sites render the same way on iPhone 4 and iPhone 3. And other device vendors have been embracing this and providing device pixel ratios, sometimes of 2, sometimes of 1.5, sometimes somewhat irrational numbers. So it's a little bit interesting, and you should definitely be aware of this concept. So if we take a look at the diagram, we can say, well, let's just draw the line at, let's see, 400, somewhere between 400 and 600. It's pretty straightforward, right? But we should remember that all these devices have landscape mode as well, in which case width becomes height and height becomes width. So the actual picture is something more like this if we take a look at the max of the 2 dimensions for phones and the min for tablets. So we can draw the line roughly at 650 pixels, and this will work most of the time with some exceptions. For example, some tablets in portrait mode, in this case, will get the phone version. So if you're specifying multiple versions of your site, you may be sharing a URL, or you may have separate URLs. If you have separate URLs, then you can declaratively define all the versions of your site in your head section. And you can do that with the link rel equals alternate. And the idea here is you specify the URLs and the associated media queries for each of these versions. This is good for crawlers that are indexing your site so that they can know which versions exist and to crawl them with these different settings. So one thing that you might want to do is, based on these versions that you've declared up front, redirect correctly. So the web doesn't do this for you. So I worked on a project called device.js, which tries to formalize this approach. And what it does is it parses the link alternates in your head section, matches the media queries, and then redirects you to the right version if necessary. So let me quickly show you how this works. So I'll load up a really simple application. this is a fake to-do list. Now, if I send it over to Chrome on my phone and switch the camera here. Let me just load it up. 1 second. Right. Okay, so I've loaded the same exact URL on both devices, but you can see here I've been redirected to the phone version. So let me do that again. I'll try loading the desktop version. Sorry. It's going to work, trust me. Could you guys turn off your internet? I should have done that Steve Jobs thing. Thanks. Let's try this one. The pipes are clogged. It's terrible. Oh, amazing. Okay, watch this. It's loading. So the same URL loaded a completely different version. So let me just show you for comparison here. The desktop version, the phone version. So it's useful to still provide a fallback mechanism so that you're able to specify a different version if you prefer it. So device.js does that as well. And here, if I switch to layout landscape mode, I may actually prefer the tablet version. So if I pick it, then I can override the default version that was served to me. And this will eventually load. So we can move on for now. So for more details about this project, take a look at the GitHub page. And you're welcome to collaborate with me on it. So that's the client-side story. So we've taken a look at both of these approaches, separate versions and one shared version. But the client has performance penalties for doing redirection. So if we do a redirect that costs somewhere between 100 and 1,000 milliseconds. On the server, we can save on that redirection in some cases. So the only problem with the server is we have much less features than we do on the client. We don't have JavaScript. We don't have media queries. All we have is a user agent string. And this string gets sent with every request. So the server can decide what to do with this. You can see it's a bit of a mess. So this is what Chrome for Android's user agent string looks like. And this is pretty much as complicated as most other browsers. You can see there's mentions of pretty much every single browser that has ever existed. I'm exaggerating, but it's kind of a messy thing to deal with. So let me show you a couple tools that can make this a bit easier. Firstly, let me show you how pervasive this use is of user agent strings on the net. So here's YouTube. If I open DevTools, and I'll turn off this screen scaling device metrics feature that I had before, I can override the user agent. So why don't I set it to Galaxy Nexus on Android 4.02. And you'll notice that device metrics have been set for me automatically based on a little database that exists in the developer tools. But when I reload the page here, now I've reset my user agent header, and YouTube has sent me a completely different version of the page. So just for comparison, this is the mobile version, and if I reload with just the regular YouTube version, it's a completely separate page. So many web properties use this server-side detection and redirect you without you even knowing. So how do they do it? Generally, they have some sort of device database. These are typically large databases of known user agents and their capabilities. And what device databases do is they try to find the closest known UA and give you information based on your client. So a couple of them are Device Atlas and Wurfel. They have drawbacks in that they're non-free for commercial use. They come in two flavors typically. One as an API service, so you can simply make a request every time you get a new client connected and ask a service somewhere else in the cloud what that user agent is. Or you can set it up yourself, but it's not that simple to do. So that's the state of the art right now. And just to recap this multiple versions idea, if you're separating your versions up front, I would recommend to start with device.js or some other similar solution in the client. Measure performance overhead, see if that performance of mobile or of client-side redirection is too high. And if that penalty is too high, then switch to a server-side user agent solution. So at this point, you're probably thinking, this guy is telling me to create multiple versions of my app. This is terrible. I'm not going to do this. And I'm thinking you're probably using a model view controller, or if not, you should be. So if you don't know what this pattern is, it is a way to separate the presentation layer of your code from the structure and data logic, business logic of your application. So with a cross-device approach, we can simply swap out the views, create form factor specific views, and serve them to the various devices, sharing a lot of code. Okay. So that's the story for multiple versions, single versions. Let's talk about some technical things about building a great UI. Firstly, what makes a great UI? On the web, on the mobile web, I would say single-page sites are examples of that. Some features of single-page sites are limited zooming. So the user gets text that's readable immediately. They don't have to pinch zoom around. Fixed headers and footers, so content that scrolls independently of one another, or having a header placed that's fixed to the viewport as opposed to your content. And smooth transitions, animations between states, as well as just loading links. The most basic, fundamental mobile thing to know is the viewport. Viewport is a virtual viewing area that's scaled down to your phone's or your mobile device's display. And you can configure this viewport by setting the meta tag called viewport inside your head. And by default, it's set to something ridiculous like 980 pixels, which is wider than most devices. You can configure it by setting its width to some value. But if you set it to a fixed value, say 320 pixels, that won't work on many devices that aren't 320 pixels wide. And you'll have the problem of when you switch from landscape or from portrait to landscape, text will be scaled in interesting ways. So the best practice here, at minimum, is to set the width to be the device width, which evaluates to be the current width for your device in its current orientation. You can see without a viewport, the text is hardly readable on the left. With a viewport set as I recommend, it's much more readable, and everyone's happy. We can even take this one step further and prevent zooming entirely to sort of be closer to the user experience of a native mobile application. We can do this by setting initial, minimum, and maximum scale to 1. Just adding that to the viewport. And note that you should separate these directives with commas, not semicolons. A lot of code samples on the web use semicolons, unfortunately. That's not the standard thing to do. Also avoid user scalable equals no, or supplement it with these media queries, or sorry, these content directives, because it's not supported in Chrome. User scalable no is not supported in Chrome for Android, other Android browsers, and some other that I've tested. So generally speaking, on the mobile web, or on any web, anywhere really, we want our animations to be smooth. And what this means is we want them to be approaching the limits of human perception. So 60 frames per second is the animation refresh rate above which we can't really tell the difference. So on mobile devices, this is hard because we have CPUs that are far less powerful than desktops. And because of this, we want to utilize hardware acceleration as much as possible because these devices come with generally pretty powerful GPUs. So an example of this, to keep an element fixed in relation to your scrolling of content. The old style way of doing this was you would position something absolutely, listen to scroll events, and then kind of jitter as you try to reposition your element every time you scroll. With position fixed, what you're essentially saying is you're telling your GPU that this is a separate layer and composite it composite it separate from my CPU. And this is a much less janky experience and much more smooth. Similar tactic applies for scrolling. Often we want sub-element scrolling. So an example here is Gmail or any two-pane tablet application. So we have a list view and a content view on the right. We can enable independent scrolling of elements with overflow auto. So this is old news. The new thing here is WebKit overflow scrolling. This is a custom WebKit property which works on iOS and Chrome for Android, and it essentially forces hardware accelerated scrolling. Let me quickly show you a demo here. So I'll send this. These are beautiful Chrome ponies. Cronies? Not sure. So I'm going to load this on the device. Mobile web scrolling. I'm going to load it on both devices. See which one's faster. It's going to be a race. So you can watch them race. Anyway, while it's loading, the idea here is, here with overflow hidden, we see we can't scroll this region at all. I'm trying to scroll, can't. Overflow auto is scrolling, but with this WebKit overflow scrolling touch addition, we get really fast scrolling on mobile devices. And this is what I'm trying to show you with this demo. And unfortunately, it doesn't seem to want to work. That's too bad. Okay, well, hopefully it'll load eventually. Okay, so scrolling. Often we want to go beyond scrolling and have transformations of an arbitrary nature, animations, etc. And we still want this to be as fast as possible, 60 frames a second. A key thing here is being able to position elements arbitrarily on the screen. You would use position absolute to do this, but this isn't slow and takes the software path. Or this isn't fast and takes the software path. So the hardware accelerated approach, which is very useful on mobile, is to use WebKit transform and WebKit translate. WebKit transform and translate transformations. This will trigger hardware accelerated rendering. Especially with Translate 3D, this gives a hint to the GPU that, hey, you're doing something fancy and probably GPU mode should be enabled. You can, of course, also do rotations and scales in this fashion. And it looks like our demo has loaded, which is great. So let me switch back to the projector here for both screens. We have our beautiful ponies, as you would expect. As I scroll the hidden, attempt to scroll the hidden view, nothing works. Auto, you can see it's scrolling, but it's kind of janky. I don't know if you can notice that on the projector. compare that to this. So this is what you get. Thanks, guys. This is what you get with WebKit Overflow scrolling touch. So on Chrome for Android, this is the basically the smoothness that you get. On iOS, you end up with bounce back effects. So and inertial scrolling as well. So we'll do questions after. So as I go into the next section, I'm going to preload this. So in addition to regular transforms, we can do more advanced things. As I alluded, we can do 3D transformations. We can apply perspective as well, and even arbitrary matrices, as in this example here, if you're into linear algebra. And we can let CSS interpolate between these various animation states, between the various animation states, by using the transition property. And here we are transitioning between, we're transitioning the transform property. We're specifying its length of time, 1 second, and an easing function as well. So both the transition and the transform property need vendor prefixes. So unfortunately, the demo here is still loading, but I'm just gonna hope that it'll load eventually. Okay, we'll get back to that. We'll have reason to revisit. So I talked a lot about output here. Let's talk about input. So for decades, 20, 30 years, more than that, this has been the input mode of computing, mouse and keyboard. And for quite a long time, even into mobile, we've had very similar input devices. This is a pretty new BlackBerry with keyboard and essentially a mouse-like implement. So the current state is much more interesting. Multi-touch pretty much changed the game completely. And one thing I want to emphasize here is touch is not the same as mouse. It's completely different. There's no hover state in touch. There are multiple touch points. The input is far less precise. You don't get the pixel accuracy of a mouse. And going forward, fingers aren't just coordinates, but they also have shape. And in the future, we have all sorts of interesting possibilities: pressure input, haptic feedback, etc. Touch interfaces, I'm sure you're all familiar with, have essential building blocks. These are very simple gestures. Well, they range from simple ones like tap and double tap to more complex ones like pinch, zoom, and rotation. And we can do all these things on the web using the touch events. So here we have touch move, touch start, and touch end. And these are pretty similar to their mouse equivalents, except instead of single coordinates, we have lists of touches on the screen. And there's a spec, and you can read more about this. So one of the first things you'll notice is the browser has its own touch behavior. So like I mentioned earlier, pinch zoom is one of them. Scrolling is another. Tab switching, as you probably saw in the keynote this morning, between tabs when you slide from the side of the bevel on some browsers. And you can override some of these behaviors using the event prevent default call in JavaScript. In IE, it's a little bit different. You can specify MS touch action none. This is IE 10. And you can even specify which specific kinds of interactions to disable. So you can say, or enable no touch interactions by default, or you can say only enable pinch zooms or only enable scrolls. Touch performance is an interesting topic because as a web developer, if you're not creating touch-specific input, you end up having events that are very heavily delayed. The reason for this is, for example, if you do a double tap, the browser needs to decide if it's a zoom gesture or if it's a click. So it waits for 300 milliseconds to wait for that second tap. And then if there's no other tap, it emits a click. So this is not great. 300 milliseconds is definitely visible. You can see the delay. And the workaround for this is to use touch end. Touch end will fire right away. as soon as you release your finger from the screen. And there's a nice guide about this on Google Developer Docs. The other consideration here is with multi-touch, events often come in very quickly, much faster than 60 frames per second. If you're touching your screen with many fingers, every single finger will fire at whatever that rate is. And if you draw, as soon as you handle the event, you'll end up just having too many things rendering at the same time, and this will be very bad for your performance. So the solution for this is to create separate handlers for input handling and create a separate animation thread, or animation timer in this case. So here I'm doing exactly that. I've got a set interval call, and the touch rendering code goes here. We can do even better in Chrome for Android, and in Chrome, and soon in Safari, and probably other browsers. We use request animation frame. What this does is it's essentially a polite request to the browser for an animation frame. So it aims to fire roughly 60 times a second. But if something is overloading the machine or the device, then it scales back in an elegant way, and you get as smooth an animation as you possibly can. So with this, let me show you an example of that. I'll switch over. The demo's already loaded. It's awesome. So for this particular demo, I'm using a request animation frame and the transitions and transforms that I showed you, that I talked about earlier, to have this pretty smooth transition experience between multiple screens. So you can see it follows my finger pretty closely, and when I let go, a transition will fire, and the content just shows up. So this is using request animation frame, WebKit transforms, and transitions. I also have another demo that I'm going to start loading now. And I'll get to that in a second, as soon as it loads. So let's talk about some of the problems with touch input. The first is, how do we handle both gracefully, right? What if we want to support both? This, right now, is not very pleasant. So what we end up with is two essentially completely different input methods, mouse and touch. And what we might do is we can extract the positions of the relevant input and then just relay them to a common handler. This, it's unnecessary boilerplate. It's not something you want to do every single time. So instead, well, we'll talk about solutions to this in a second. The other problem, before I talk about solutions, is gestures are difficult. So you saw that list of gestures that I showed you that are common for mobile devices. But doing such a thing without gesture events, which are only available on iOS, is pretty hard. So here's a pinch zoom snippet that recognizes the pinch zoom gesture. It's a lot of code, and doing this every time you want to pinch zoom is just not reasonable. So Microsoft has a input model that they're planning on using for Metro. It's called MS Pointer, and the idea is to consolidate input, to consolidate mouse, touch, and pointer into one single type. And of course, you can still distinguish between mouse and touch with an event property. And it's a really nice idea. I like it a lot. The problem is, with the current proposal, it's essentially just another input mechanism to deal with. So now you have the mouse handler, the touch handler, and the MS Pointer handler. And it's just not necessarily great. So Pointer.js is a project that I worked on to try to consolidate this input problem between browsers, using a similar idea as MS Pointer events, except to take all these different event models and make an abstraction layer around them to make it really easy for developers. So let me show you this in action. And here I have a space shooter. And actually, let me show you this on the device instead. So this is a demo that was created by a friend of mine called Seb. And you can see it's essentially just a space shooter thing demo. It's kind of neat because you can place your control anywhere you want and then just shoot anywhere on the right side of the screen. So this is using pointer events. And one of the benefits of this, it was initially using just touch events. So on the desktop, nothing would work at all. And with pointer events, though, I can have essentially the same experience on both mouse and touch input. So this is a quick and straightforward pointer example. Pointer.js also aspires to have gesture recognizers on top of the consolidated input model. And for more details about this, check out the project page on GitHub. So let me quickly talk about mobile web development. One second. So I've been trying to show you some features of the Chrome developer tools as we go. And of course, the easiest path to getting started with mobile development is to emulate it on the desktop. You don't have to deal with extra devices. You don't have any of that headache of having to touch around all the time. So it's nice. And I've shown you how to emulate screen size, how to override the user agent string. And let me just show you one more thing. This is part of the mobile Chrome experiments that you may or may not have seen. If you haven't seen it, check it out. It's on the second floor in the Chrome booth. So this is a Chrome experiment, and it's essentially a scroll view with a twist. So to show you the twist, I have to scroll, but you'll notice here that it's using touch events. And when I try to scroll, nothing works. So let me open up DevTools and show you a cool feature that's very useful. I can emulate touch events. So what this will do, when I reload the page and switch back to it, now when I mouse around, these mouse events are being translated into touches. So instead of a mouse down, I get a touch start, etc. And you can see this is using, again, a request animation frame. And Hakeem here has a whole bunch of cool effects to just give you a sense of how performant you can have these nice transitions on both Chrome. And it works just great on Chrome for Android as well. You should check it out in Chrome Experiments booth. So that's some Chrome DevTools features. You can also emulate multi-touch events on the Mac. And this is a fun little project that I worked on. It requires a bit of setup. But once you've got it set up, then you can essentially create multi-touch prototyping. You can do multi-touch prototyping on any Mac with a Magic Touch trackpad. So here you can see I've got a single touch that's coming from my Mac trackpad, and I can do multiple touches too. And I can do this arbitrarily. So it's kind of cool if you're doing complex multi-touch interactions. This game is just like a Fruit Ninja clone that I whipped up, except with browsers. Doesn't really make sense. You hit the blink tag and you get a 406, right? Anyway, so that's multi-touch. And of course, you want to test on your device, ultimately. You can do these emulations, you can use these tricks, but ultimately you need to test on your device. And Chrome for Android has great support for remote debugging, and we have plenty of resources about that. In the interest of time, I won't burden you, but you should check it out, and I'll make these slides available afterward. So thank you all for listening. We've got some time for questions, and so yeah, right, we have microphones on both sides, so feel free to ask anything, and I'll be available in the Chrome area as well afterward.
I guess the mic's off. There we go.
I think it's on.
You showed examples of how to get the GPU hardware acceleration enabled.
Mm-hmm.
Why aren't those turned on by default? Why do you have to play tricks to get it to work reasonably?
Right. So this is, I agree, a problem that we are tackling currently. So the Chrome GPU team is working very hard to try to make more of the rendering part of the GPU pipeline, essentially. So, like you're saying, part of the problem is you don't really know which tricks will render GPU mode, which ones won't. It's very implicit. And generally, of course, the whole rendering path should be done on the GPU as much as possible. So GPU team is definitely looking at this and trying to optimize as much as possible.
Okay.
It's on their radar.
All right.
Yes, go ahead.
So if you're trying to emulate more kind of a mobile native experience, the address bar gets in the way, is there anything more elegant than just scroll 1 pixel when your app starts up?
Yeah, so, right, as you're saying, the current hacks are around using scroll to, which is a JavaScript function that you just call and say, scroll to the top. And in most browsers, in some browsers, it'll hide the location bar. We're working on evaluating what full screen API might look like. So this is an example of, there's an open web API that lets you make a browser go into full screen mode. So this would be a nice application. That said, right now in Chrome for Android, we have a omnibux that's always there. And there's good reasons for that as well. Mm-hmm. Just if you have your URL bar always present, it's an indication that you're in the browser, you're not being fished, you know exactly where you are. And it's also very easy to navigate away, like to any other page. Oftentimes on iOS, I'll have a hard time getting back to the URL bar, especially if someone's overriding the default scrolling behavior.
I see. You
hard to
can't
get
pull
back.
it down.
So, but yeah, I agree. It's totally a hack.
Should be a new GitHub project for you, fullscreen.js.
Thanks. Yes.
I was just wondering, you were always saying it's supported on iOS and on Chrome for Android. What about the stock browser that gets shipped?
Right. So the stock browser on Ice Cream Sandwich is actually quite good. And there's a lot of, there are many features that are supported on it that I discussed today. Don't quote me, I believe request animation frame maybe. Anyway, the inertial scrolling certainly is. So, yeah. Thanks.
Yeah, I was curious. So we provide a third-party widget that you embed on your page, and so we don't have control over things like the meta tags and some other stuff that you showed. And I'm kind of curious. We were thinking of using the new implementation of position fixed to allow our chat box to show up.
Yep.
But you don't get kind of zoom fixed on that. So when you zoom in, then eventually this position fixed thing just takes over the whole screen.
Yep.
Is there anything new that could take advantage of?
Yeah, it's a good question. Position fixed is a little interesting if you don't have control over the fixed viewport, because it actually varies quite a bit in its behavior depending on browser.
Yeah.
So, yeah, I think you have a pretty unique case in that you're like a third-party JavaScript plugin. I can't think of anything off the top of my head that you could do that with. Maybe we should talk offline.
Sure thing. Thanks.
Great. Thanks. All right. No other questions? Find me later. I'll be hanging out in the Chrome booth.